All right, today we're going to build your very first data science toolkit. We're going to unpack the core ideas that, decide everything from what you see on your social media feed to your search results. The goal here is to give you the mental tools to see how machines actually think.
So here's the big question, right? We are just drowning in this avalanche of information. So, how do machines learn to find the signal in all that noise? I mean, how do they actually spot patterns, make predictions, and at the end of the day, make sense of all this chaos?
And that is exactly where our toolkit comes in. In the next few minutes, we're going to unpack three essential instruments. First up, we've got a group sorter for finding those hidden patterns. Then we've got a predictor for making smart, educated guesses. And finally, we'll look at the report card to see how well our machines actually did. So, you ready? Let's grab tool number one. Okay, so tool number one, the group sorter. This one is all about pure discovery. Just imagine you're handed this massive pile of data, but with a catch. No labels, no instructions, nothing. Your job is to just turn to the machine and say, all right, what's hiding in here? Show me the natural groups. Now, the fancy technical name for this is unsupervised clustering, and the most famous tool for the job is an algorithm called k-means. The name kind of gives it away, doesn't it? The k is simply the number of groups you're looking for, and means, well, that just refers to the average, or you could say the center point of each of those groups. So how does this actually work? Well, it's this beautifully simple back and forth dance. First, you pick your k. Let's say we want 3 groups. The machine then just randomly drops 3 starting points, we call them centroids, right into your data. Then step 2, every single data point gets assigned to whichever centroid is closest to it. After that, the centroids themselves move to the new center of their freshly formed group. And you just repeat. Assign, update, assign, update. You keep doing that over and over until the groups just stop changing and everything is stable.
But in any group, you're always going to have a few oddballs, right? Those data points that just don't seem to fit in. Well, in data science, we have a name for those: outliers. And it turns out not all outliers are created equal. Okay, so you've got 2 main types. First, there's the global outlier. This thing is weird no matter how you slice it. A student who's 250 centimeters tall, that's an outlier in any classroom anywhere on the planet. But then you have the local outlier. This one is only strange in its own little neighborhood. For example, 20 degrees Celsius is a totally normal temperature. But if it's a single day in the middle of a blazing hot summer, that's a local anomaly. See? It all comes down to one simple thing: context.
All right, we've sorted our data into groups. Nice. Now it's time to actually make some predictions. And this brings us to tool number 2 in our kit, the predictor. Here, we're shifting gears a bit. We're moving away from that unsupervised discovery and into supervised learning. This is where we actually teach the machine using labeled examples.
The technical term for this is classification. And one of the simplest, most intuitive tools for it is something called the k-nearest neighbors algorithm, or KNN for short. Now, what's really cool about KNN is that it's known as a lazy algorithm. And why is that? Well, because it does literally no work up front. It doesn't build some complex model or anything. It just stores all the data and basically chills out until it's time to make a prediction.
Let's see this in action with a really simple story. Imagine we've got a data set of fruits. We know their weight, we know their texture, but then a new mysterious fruit shows up. The question is, based on its neighbors, is it an apple or an orange? So here's what we know. We have 2 apples, they're a bit lighter, a bit smoother. And we have 2 oranges, they're heavier and not as smooth. Our new mystery fruit comes in at 135 grams, and yep, it has a smooth texture. So, what do you think? What do its neighbors say? This is where our lazy KNN algorithm finally wakes up and springs into action. First, it calculates the distance from our new fruit to all the others. Then, it finds its k closest buddies. In this case, we'll say k equals 3. And when it looks, its 3 nearest neighbors are 2 apples and 1 orange. So now, it's time for them to vote. And the majority wins. Our new fruit is officially classified as an apple. It's that simple, super intuitive, right? And yet, it's a surprisingly powerful little tool. Okay, so let's recap. We've grouped our data, we've made a prediction, but how do we know if we actually did a good job? I mean, how do we grade our work? That brings us to the final, and you could argue the most important tool in our kit, the report card. Yeah, the machine made a guess. But how do we know if it's doing a good job? Just because it spits out an answer doesn't mean it's a good answer. We absolutely need a way to grade its performance so we know if we can actually trust its predictions. Now, two of the most critical grades on this report card are called precision and recall. They sound kind of similar, but trust me, they measure very, very different things. Precision asks, when the model predicts yes, how often is it correct? It's all about avoiding false alarms. Recall, on the other hand, asks, of all the things that are actually yes, how many did the model find? This one's all about not missing anything important.
Here's a great analogy for precision. Imagine your friend points to a bunch of apples and says, "Hey, all of these are ripe." Precision is just asking, okay, of all the apples your friend said are ripe, how many are truly ripe? You care about high precision when the cost of a false alarm is high. Think about your email spam filter. You really don't want it to incorrectly flag an important email as junk. And for recall, think about a metal detector at the airport. You really don't mind if it goes off a few extra times for a belt buckle, right? That's a false alarm you can live with. But what you absolutely positively cannot do is miss a single dangerous item. So there you need the highest recall possible, because the cost of missing something is, well, it's catastrophic.
Okay, and here is a super important warning about the one metric you probably hear about the most, accuracy. It can be so misleading. Get this, imagine a model that's testing for a rare cancer that only 1 out of 100 people has. A model that just predicts everyone is healthy every single time will be 99% accurate, but it has completely, utterly failed at its one important job. And that is exactly why we need tools like precision and recall.
So there we have it. Our three main tools are in the kit: the group sorter, the predictor, and the report card. Now let's put this toolkit to work and see how it's secretly running the internet you use every single day. The whole shebang is called web mining, and it really comes in three main flavors. First, you've got web content mining. This looks at the actual content of web pages, the text, the images. Think about analyzing tweets to see if they're positive or negative. Then there's web structure mining. This focuses on the links between web pages. This is the secret sauce behind Google's PageRank. And finally, there's web usage mining. This one watches your behavior, your clicks, your history, and yeah, that's what powers the recommendation engines on Netflix and Amazon. And there you have it. That's your first basic data science toolkit, with just these three core ideas: finding groups, making predictions, and then grading the results. You now have a brand new lens to see the hidden logic that's shaping our entire digital world. So now the question is, what hidden patterns and predictions will you start to see in the world around you?